Hello, welcome back to the Python video tutorial series. Today we're covering Python 2, functions. This video is part 1. We've split it into 2 parts so that the video times aren't too long. So let's begin and jump right into Jupyter Hub. So here we are, functions. Today we're going to be covering the length function, the append function, which we've seen already, parameters, and multi-parameters as well. So functions appear everywhere in Python, as we've seen, and functions follow the syntax: function name, the inputs listed in order, separated by commas, and enclosed in rounded brackets. And that's what a function is in Python. We're going to make a comparison to mathematics to help you understand and relate it to something that you're already familiar with as well, and maybe help you to understand maths as well, just learn a bit more about functions. So you've heard of a function from mathematics, no doubt. Let's compare the similarities to help us understand a computing function. We'll use some of the content from Python 1 in this explanation as well. So here we have a function. It looks very familiar. I'm sure you've seen this if you've done higher mathematics or A levels or any international baccalaureates or whatever your educational background is. The function is a quadratic function. You can tell that from the x squared function. It says f of x is equal to x squared plus 3x plus 2. That's how we say that function. It's a function for maths. So this function has a name. The name is f, just like a name in computing, like the print function or the length function or append. It could also have the name function, but mathematicians love to be concise, so it's just f. The function also has an input parameter x, which is enclosed by the rounded brackets next to the function name. And the output of the function is determined by the behavior of the function. In f, this behavior is a mathematical calculation using x and other mathematical operations like indices, multiplication, and addition. And we can actually code this mathematical function in Python as well. So let's see that below. So down here, you won't need to know how to do this. I'm just showing you as an example. If it interests you and you think, maybe I could use this in my own lab work or any other subjects, this is what it looks like to define your own function. But let's see. So we've got def, which is a keyword for define. And then just like the layout here, I've got the name of the function, f, and enclosed in rounded brackets, I have an input parameter, a formal input parameter, x. I call it formal because when you're defining the function, you give each parameter its own name so that you can define the behavior of the function below in the definition. So here, down below, also don't forget to use your colon to signify that you're defining a function, and then press return. And when we define the function, the body of the function is indented. Python uses indentation for different procedures and just to show what takes precedence over each other. But we don't go into that in physics. Don't worry about it. Sorry, I'm just blabbering on about computing science. So we've got the return keyword, which means our function is going to return this calculation here. We've got x, and we're using the exponent operator here, x squared plus 3 times x plus 2. And when first we execute the cell. And when we execute the function, okay, I've inputted 1 as an actual parameter into my function f. I've assigned it to my answer, and when I print it out, we see that when you put 1 into this, so 1 squared is 1, plus 3 times 1 is 3, so that gives us 4, and then plus 2 is 6. So when we print the value held in my answer, we get 6. That's the comparison to mathematical functions. Although you don't need to know about defining your own functions, you may find them useful for printing your own graphs. We'll get into for now, do not worry. It will be covered in a much later video after you've undergone some basic Python training. This is still basic Python training, but we'll get past that, don't worry. So, intro over, into the functions. Most people first meet the print function when learning Python. Print is used to display the value held inside a variable, or simply to display something on the output screen. Various examples are shown below of print. So we've already seen print. Brackets can have no spaces, like we've got here, just print x, or as many spaces as you like. So here we've got really uneven, big, messy, don't know why you'd ever do this in your whole life. It's crazy. But it's the arguments that matter, and the arguments are determined by the commas put between them. So it's the commas that matter, not the spaces. It's just for people to know when you're writing out functions, you think, oh, is there certain rules that I can't break? No, not really. You can put in as many spaces as you want. It's the commas that matter. Here we've got x, there's spaces in there and it still works. Y equals 2, print y plus 2. Here we've got a calculation being done inside the print statement. So if y is 2 and we're adding on 2, we should get 4. And then we've got a list here, and we can print out my list as well. And we can see it prints out 1, 2, 3, 4. Nothing changed, nothing weird about that. Familiar with that from Python 1 that we've just covered. Okay, the length function. So it's not actually length that you write, it's len. Everything's sort of shortened. Everything tries to be as concise as possible because you'll be typing a lot of stuff in computer science and physics. So the len function returns a number which indicates the length of the input to the len function. The input to len must be a type of data structure, like a list or a tuple. It cannot be a single number, like an integer. What is the length of 5? How long is a piece of string? I don't know. Or something that cannot be described as having a length. Strings are valid inputs, and it will return the number of characters in the string. Inputting a list to the argument of len will have the function return a number representing the number of entries in a list. Okay, so if we have z equals 5, and we're trying to find the length of 5, is this going to work? No, it's not. It's not going to work. What were we thinking? It gives us a type error. It says object of type int, integer, has no length. How can an integer have a length? It doesn't. So we get an error. So that's not valid. You can't do that. But here we have a list which has various numbers. We've got a string in there. We've got integers. We've got floats. When we get the length of this, it's 10. And sure enough, if you count it yourself, you'll see that there are indeed 10 entries in that list L. So storing in variables. In the above example, just scroll up to see it. In the above example, the Jupyter cell, once executed, returns the output of the length function. However, the data returned has not been stored in a variable. We don't have that value 10 anywhere to use. We can't use it again. It's been lost. We need to store it. We should have a variable to hold the value returned by the function. Functions can be thought of as representing the values of their outputs rather than an operation being performed. So you can imagine length L being our list, as representing the number 10, because that's what it outputs. It outputs the number 10, so we can treat it as a number 10 as well in any calculations. We don't need to think of it as just performing an action. We can think of it as data. So in this way, we think of functions as data that can be used. For example, the function with a list as the argument, length, and then a list of 0, 1, 2, 3, 4, is equal to the number 5. We can use this function in place of the number 5. This is what we mean by thinking of the functions as the values that they return. Here is a code example with a function and its output being assigned to a variable. So we've got my list here, collection of odd numbers, and the list length is equal to len my list. Now we can use print list length to show us that the function has indeed returned a value, and it's being held in the list length variable. Okay, the function has outputted a value, and it's now being held in list length. And we can print out list length, and we get 7. That's the amount of entries that are in our list. Okay, so that's what length does. It just tells you the number of entries or the length of a data structure. Now on to append. We've actually seen append in the previous one as well. We're just going to quickly cover parameters and specifics. So the append function is a bit different to the others as well. It's not like print. Append is typed after the variable name that holds the list you're appending items to. Append will add a single entry to the end of the list. So an example follows below. We've got my pets. I've got a cat, I've got a dog, I've got a fish. I can print out my pets. That'll just print this list. I've just gotten a new pet guinea pig, and would like to add it to my pets list with the dot append function. So when we do my pets dot append, and then inside we have the item that we'd like to append to our list. In this case, it's a string that says guinea pig in here. We do not need to create a new variable, as the list is already held in memory. The list is held in the variable my pets. We're just adding a new thing into the memory. We're simply altering what is held in the memory space. My pets will continue to point to that space of memory holding our list. So when we execute this cell, we'll see the old list and the new list. Sure enough, after executing .append, we can see that it's been added onto the end of the list. So it's worked. Now, a very important thing here. This is majorly important. Listen, pay attention now. Documentation sheets, they're help sheets. They tell you what to do. So all of these things that we've covered are basic built-in Python functions. There are a lot more functions in Python, but you will only need a handful of them. When you come across a new function and don't understand how to use it, this will happen all the time. Search it up using the sort of layout, like the function name and then documentation Python, and you will find the official instructions provided on using that function, including parameters, return values, and restrictions on input types as well. So you should do this every time you come across a new function in order to find out how to use it, okay, and understand what your code will do. So an example, I don't know if this is going to capture it, but if I search up print documentation Python, sorry if the camera's a bit shaky. So we can see we get this built-in functions, Python 3.14, 3.11.4, sorry, it looked like pi, documentation. Click on that, and here we go. Look at all these functions. These are built-in functions. We can go down, where's P, here it is, print. Click on this. It gives us the name of the function, and look at all these different parameters as well. So it gives us loads of information on classes and all sorts of things I'm not going to cover. But that's just an example of how to use documentation sheets. They're very important. I recommend that you use them. If you don't know how to use a function, documentation sheets, documentation sheets, documentation sheets. You got it? Okay. I promise I'm not that unhinged. Maybe a little bit. Right, this is the end of part 1, and I'll be back in part 2, maybe. I think I will. I will be back in part 2. See you then.